Good morning, everybody. I hope you're doing well today. Today we're going to be doing solving systems of equations by graphing. And so what is a system of equations? A system of equations is two or more equations that share the same set of variables. And so what is the solution of a system of equations? Where the equations intersect on a graph. So we're going to get a look here in a moment at what that's going to look like. When solving a system of equations by graphing, you're first going to rewrite the equation in whatever form is easier for you. My recommendation is slope-intercept form. I think that's the easiest, but you can also rewrite it in standard form to solve it by graphing the intercepts. Remember, we use the standard form for graphing the intercepts. Graph both the lines on the same coordinate plane. Be careful and make sure that you're neat. Especially make sure that your lines are straight. That way you can see where they're intersecting, but I'll also show you guys another trick for that as well. Find the point of intersection and determine what the x and y coordinates are. Make sure you're answering it as x comma y. And then you can also the last step is optional. You can double check your answer by plugging the x and y back into both equations and making sure that it works. So this first example, we have y equals 2x minus 3 and y equals x minus 1. These are both already in slope-intercept form, and so we're going to go ahead and graph them in slope-intercept form. Just a reminder, slope-intercept form is y equals mx plus b. The b is the starting point. So whatever is that the number without x, that is your starting point on the graph. And so I'm going to do this first equation in red, and I'm going to do the second equation in blue to be able to highlight where they're at better. So since it is a minus 3, that is going to tells us our y-intercept is negative 3, and a y-intercept is right down here. Again, the y-intercept is simply where your line is going to cross the y-axis. And so since it is a minus 3, that tells us our line will cross there. And your slope is 2, technically 2 over 1. So that tells us that we are going to, from our y-intercept, we are going to rise 2 and run 1. You also could go down 2 and left 1. Both of those would work. And you end up with this line here. Oh, the end of that line sucked pretty bad, but that's all right. You get the picture. And now I'm going to do the other one in blue. So again, the y-intercept is a negative 1 here. And so that means we're going to start our graph by going down 1. Your slope, we don't see 1, but it is 1 because there's no number there. We know it's just automatically a 1. So that's 1 over 1 technically. And so we rise 1 and run 1. And then you can go ahead and straighten out your graph. Oof. So as you can see, if I try to do my line straight by hand, it's not going to go very well. So if your lines aren't straight, my recommendation is to just keep doing the slope over and over again. So it was up 1 over 1, it was up 1 over 1 again. And so you can see where it's going to intersect there, but up 1 over 1 again right there, yada, yada, yada. So this is what it should look like. But again, your points are not always going to be perfectly straight. Again, if I look at the red line, the slope was 2 over 1. So if I keep doing 2 over 1, it does intersect right there at this point right here. So continue doing your slope over and over again for both lines, and that will also help show you where it's going to intersect, because sometimes we don't draw our lines perfectly straight. I just used a straightening tool, and I still didn't get my line perfectly straight. So yeah, go ahead and just look at the slopes and continue doing the slopes over and over again. Now that we've graphed them, we found the intersection. That tells us the solution is going to be 2, 1, because that is where our two lines intersected one another. And that's how you're going to graph using slope-intercept form, or just you can use any form, but I would recommend using slope-intercept form. And that's how you graph a system of equations. And we could plug the 2, 1 back in to both equations to see if it's correct. So it would look like this. On the left here, 2 times 2 is 4, and minus 3 is 1, and 1 does in fact equal 1. And on the other one, 2 minus 1 is 1. So they do in fact equal 1. So that tells us that we did do it correctly because both of these were correct solutions. So that's how we're going to do it. Let's go ahead and look at some special situations now. So this first one here, one of these equations is in slope-intercept form. The other equation is in standard form. So I'm going to convert the standard form one into slope-intercept form by subtracting 2x on both sides. Again, slope-intercept form is when the y is by itself, and so we have to get rid of the positive 2x by minusing 2x. So now we have these two equations, and I'm going to go ahead and graph them. The y-intercept for this equation is -5 because of the -5 right there. So I'm going to start by going down 5. And then the slope is -2, which is technically -2 over 1. So I'm going to rise 2 and then go to the left 1. You could also go down 2 into the right 1. Both of those would work. And so this is going to be our line here for this one. And the other one I'm going to go ahead and do in blue. It's -2 plus 1. So the plus 1 tells us that we have to start by going up 1. And the slope being -2 tells you that you rise 2 and go left 1, or go down 2 and right 1. Either one of those works. They're both on our line. Now, the solution to a system of equations is where the lines intersect. But these lines aren't intersecting. That's because these lines are parallel. That is why this is considered a special situation. The lines are parallel. So since it's a special situation, it's going to have a special answer. The correct way to answer this would be no solutions, because they will never intersect, which our intersections are where our intersections are the solutions. And since there are no intersections, there can be no solutions. Now, how can you tell this is a special situation without graphing the equation? Look at the slopes. The slope of the first one was -2. -2, not -2x. Let's be very clear on that. People get that wrong in the checkpoint every year. It is -2. The slope on the other one was also -2. So since they had the same slopes, they were going to be parallel. So same slopes. So I'm going to have you guys go ahead and pause the video, try to do this next one, and see what you can figure out here. Alrighty, so if you would pause the video and you could solve this to figure out, to put it in slope-intercept form, this would be 4y equals -2x plus 8. Divide both sides by 4. Y is going to equal -1/2 x plus 2. And so if we graph -1/2 x plus 2, the plus 2 tells you to go up 2. And the -1/2 is to go up 1 and over 2, or down 1 and over 2. And so we end up with this equation here. Or sorry, we end up with this graph here. Sorry for the straightness. And the other equation, well, the other equation is actually the same thing. It's y equals -1/2 x plus 2. So we start by going up 2. And then the slope is rise 1, run 2. And we go out the direction. And so we end up with, well, the same exact thing. So why is this considered a special situation? Because the lines were the exact same. The lines were overlapping. So what is the correct way to write this answer? This answer would be infinite solutions, because every single point on that graph was on our line. Every single point on the lines were intersecting. And so since everything is an intersection, that means everything is an answer. And we can tell this is a special situation without graphing the equations, because the equations were the exact same. So on your guys' homework tonight, you will have 3 different possible answers for a question. One answer would be like the first one, where your lines intersected at one specific spot, and so the answer was one specific ordered pair, 2, 1. The second answer could be no solutions because your lines were parallel, and the third would be infinite solutions. If you guys have any questions, please let me know. I hope you guys have a